Question about that's related to this about Marshallian demands. So what of these are these facts that we've got here also true of Marshallian demands? Well, okay. So there's who actually spoke? Okay, yeah. So there's a claim that that Marshallian demands are always downward sloping. So let's see. Do we think who agrees with the claim that Marshallian demands are always downward sloping? Okay, who disagrees? Who assumes it's a trick question? Yeah. Okay, so let's see. I mean, so the statement in words that the Marshallian demand curve is always downward sloping, we can express in a way that's analogous to this one. So here we said, actually incorrectly, you write this down. So Hicksian demand curve, downward sloping. We can put in mathematical terms by saying the partial derivative of the Hicksian demand with respect to its own price, so let's call this good 1, is going to be less than or equal to 0. So we have a similar statement, and this is true. That's something we can prove. I haven't really proven it, but one could. The analogous statement for Marshallian demands would be what? What would we have here instead? Yeah, it's just the partial of the Marshallian. So x1 in this case, dp1. And then the question is whether this is less than or equal to 0. Now, if it is, if this inequality is satisfied, then the downward sloping thing is also true for Marshallian demands. Okay, so I'm going to erase this one. So we're going to ask about this inequality. But we know something about this quantity that we've talked about quite recently. What can we say about this thing? We can decompose it using the Slutsky decomposition. We know from last time that this is equal to dh1 dp1 minus dx1 dy all times x1. So now the question is this less than or equal to 0? Okay, so is that clear? Now, we still don't have an answer to the question. We're making some progress on breaking it down to pieces we can establish. Okay, so is this less than or equal to 0? Well, what do we know about the terms that appear in this expression? Yes? Okay, you're jumping to the conclusion, which is excellent, but I'm going to take baby steps to get where you're at. Let's see. So what do we know about the terms that appear here? Okay, so this piece is always negative. That's what we just established, or just claimed at least about Hicksian demands. So this part is less than or equal to 0. That's fine. Now what about this piece? If we always knew that that dxy dxi was positive, then we have a negative number subtracting a positive number, and this would be true. Okay. Now Scott points out that we don't know about the sign of this thing. It depends, and specifically, it depends on whether or not x1 is a normal good or an inferior good. Okay. Now, so suppose, so first of all, if it's a normal good, then what's the sign of this? It's positive, so we're done. So we can say right off the bat, for any normal good, we have dxi dpi less than or equal to 0. So we're done with the normal good case. What about inferior goods? If it's an inferior good, does that mean the Marshallian demand curve is going to go up? Yeah. So Tom says it's going to be a race of magnitudes. Let me just rewrite this piece here. So we're going to have it be downward sloping if dh1 dp1 is less than or equal. I'm just going to add this to both sides to dx1 dy times x1. Okay. So this is the condition that's both necessary and sufficient for the Marshallian demand curve to be downward sloping. Okay. Now this thing over here is a negative number, so it's always going to be less than this if this is a positive number. But if this is an inferior good, this will be negative. For the Marshallian command curve to be sloping upwards, this magnitude has to be larger in absolute value than this magnitude. So we'd say that the income effect dominates the substitution effect in that case. Okay, now it's difficult. I think I said this before. It's difficult to find cases, sort of real-world cases, where this happens. It might be. Let me write this in the same claim in elasticity form. It might be a little easier to think about. So in elasticity form, we have this substitution. Looks like this. Okay, so that's the elasticity. That's the elasticity form of the same statement. So this could dominate only if it's very large in magnitude. What it would take to be large in magnitude is that the expenditure share for the good would have to be very large, and the income elasticity would have to be very large. Any thoughts? Any thoughts about what goods might have those properties for some people at least? You say ramen? Oh, ramen noodles. Maybe. So if your expenditures were low enough so that ramen noodles made up a large piece of your total expenditures, that would help. It would also have to be the case that how much ramen you consumed depended a lot on how much your income was. And for most goods we think of, if it's a big part of your expenditure share, you also tend to be kind of income inelastic. So if you lose some income, you might not change your ramen intake a lot. There is an example, so an old textbook example that most economists believe is false now, would have been potatoes during the Irish famine. So the claim there was that the potatoes made up a really large part of expenditures for some poor Irish households, and that was certainly true. And when the potato famine came along, people got a big decrease in income, and their share of potatoes actually fell a lot because they switched. Well, they must have switched to something else, eating moss or something. I don't know. I don't remember. I think there's general agreement that was the case. There's a recent paper about a poor area in China, though, that claims that rice satisfies this property for some very poor households there. So rice ordinarily makes a large proportion of the expenditure share for those households. If there's a decrease in income, though, they can switch to other cereals that they don't like as much. So there's a pretty big income elasticity as well. And so Rob Jensen, who's now at UCLA, has a nice empirical paper where he argues that rice for some particular poor areas in China has this property that the demand curve is upward sloping over some regions at least. By the way, if the curve is sloping upwards, we call that a Giffen good, named after the economist who first noticed that they could slope upward. Whose first name escapes me. Do you happen to know, Jeff? Okay, so this first property that's true for Hicksian demands. Hicksian demands are always downward sloping. Marshallian demands generally are, but they don't have to be. And there may be real world examples where they're not always downward sloping. Yes.
Someone's asked, like, if Marshallian demands are always downward sloping, you say, like, false.
I would say false. That's correct. Yeah.
Even though it's only rare circumstances where you
The word always means always. Yeah. Yes. Okay. So let me try to say this carefully. If it's a normal good, it slopes downward. If it's an inferior good, it might possibly slope upward over some part of its range at least. So being it's necessary for it to be a given good. It is necessary, but not sufficient for it to be an inferior good. Yes.
Can you explain the left side of that equation a lot? And, like, has to have a big expenditure to know?
This guy here. Oh, this part here.
Yeah, it has a big expenditure there and
And it has to have a large income elasticity. This is the income elasticity of the good. And it has to have a large expenditure share. Is that? Shall I say more? You don't look. You still look. So for a graph here, let me see if I can do this. I'm going to make an effort here to draw you a picture where we get a given good. But bear with me. This is don't try this at home. I'm not sure I can do it here. Let me see if I can now. So the idea is going to be this. I'm going to have an indifference curve. There's going to be a big budget share initially for one of the two goods. So I'm going to say this is your budget set. And so we're going to spend most of our money on good 2. So good 2 has a big budget share here. That's good. Now I want there to be an increase in the price of good 2. If there's an increase in the price of good 2, what's going to happen to this budget set? Yeah, I didn't draw it very well. I've already screwed up. It's going to get flatter. Let me draw it a little more reasonably. So it'll but this will be fixed. So it'll do something like that. Okay. So we want to start off with a large budget share, and we want to think if we can draw an indifference curve so that the increase in price actually moves us so that we get it. I can't have it here. I have to have it down here. So the increase in price actually leads to an increase in demand for a good 2. So something like that. So can I draw a set of indifference curves? Are going to be different indifference curves to move me from here to here? Maybe. It's not technically impossible. I mean, sort of the Slutsky equation tells me that I should be able to do it. That doesn't mean I can do it. But if we have, I guess, indifference curves that look something like this, that gives the outcome we want. So an increase in price of good 2 leads to an increase in demand for good 2. What's going on here is a little bit weird. As we're decreasing income, we're increasing demand for good 2 a lot. So okay, so there's a picture of where it works. I had to make it work. I had to do something kind of funny with the slopes. How the slope of this, the point on the indifference curve where the slope of this is equal to this over here is way over here. So it's a funny arrangement of slopes of those indifference curves. Okay, enough of that. Okay, so we talked about Marshallian demands don't have to be downward sloping. Here's a case where they wouldn't be. How about homogeneity in prices for Marshallian demands? Is there anything we can say about the homogeneity of the Marshallian demand? Let's just try an example. Suppose we have our usual x1 equal to alpha times y divided by p1. Homogeneous in prices? Well, not homogeneous in degree 0. If I multiply this by d, this gets smaller by a factor of b to the minus 1. So this is in fact homogeneous in this particular example. It's homogeneous in prices, but it's degree minus 1. How about homogeneous in prices and income? What if I double income and double prices? Okay, so that's true for Marshallian demand curve. So for Marshallian demand curve, if we double prices, all the prices, and double the income, then it doesn't change demand. So it's homogeneous with degree 0 in that case. You can think of that case as being, it could be all prices and income double. You can also just think of it as like a change in units. Suppose that we decided that instead of measuring income and prices in terms of dollars, we decided to do it in cents. That would have the effect of increasing prices and income by a factor of 100, and we wouldn't really expect that to have an important effect on demand. Okay. All right. How about cross partials being equal? Is that something we think might be true for Marshallian demand curves? Yeah, maybe? Is that? Yeah, we need the. Well, so let's go back to our friendly Slutsky decomposition. So suppose we have the cross price Slutsky that we can use here. So we said before that we'll have something like this. Sorry, that's I and j. That's equal to dhi dpj minus dxi dy all times xj. I think I got that right. And then the question is whether that's equal to dhj dpi minus dxj dy xi. This is equal to dxj dpi. Right. So the question about symmetry is this equal to this? And in the middle, I just use the cross price Slutsky equation. And so that's where the question mark goes. Okay. So are those things equal in general? What can we say about that? Okay, we've got an important fact here we can use. That's this one. dhi dpj is equal to dhj dpi. So that's good. This cancels with this. So now we're left with the question of whether dxi dy times xj is equal to minus dxj dy xi or not. Is that true in general? Will it ever be true? So a little louder. Let's remember how we wrote this in elasticity form. This is the same as asking, well, first of all, I can get rid of the minus sign. So this is the same as asking whether or not dxi dy y xi is equal to pj xj y. So this is the elasticity form of the same thing. Okay, so are those guys always equal? what's the name for the thing on the left? What's the name of the object on the left-hand side? Okay, so this part is the income elasticity of good I, with a good I. This part is the income elasticity of good J. What about this piece here? The expenditure share of good J. Here's the expenditure share of good I. So are those two things going to be equal in general? Yeah, even if the expenditure shares are the same, if the income elasticities are different, these things won't be equal. So what we really need is well, if the income elasticities are equal, then we'll get equality. Yeah. I'm not sure how to. So let me come back to that. Okay, I'm not sure I understand the question. So here, what we need for dxi dpj to be equal to dxj to dpi is we need this piece to be equal to this piece. So we need the income elasticities to be equal. Okay, let me ask. Can you repeat your question, please? Oh yeah, that's right. Oh, you say what? So the question is whether or not, if this is satisfied, we shouldn't just regard them as being sort of the same good or part of the same bundle, if I understand the question correctly. So I would say the answer is no. I mean, even though this isn't true in general, even for some of the example utility functions we've worked with, so if we have x1 equal to alpha y over p1, for example, do you remember what the income elasticity is associated with this? It's 1. And same thing for, for a good 2, it has a 1 minus alpha in there. So what you need for symmetry there, and we use this to model things like food and clothing, so you wouldn't necessarily want to throw those into the same bundle. So this can be satisfied, even for goods that aren't so likely we treat them as the same good. Okay. All right. Okay, other questions about this? Yes? I'm glad you asked that question. I may come back to this a little bit later, too. Let me just draw the picture you've asked about. So for those of you who have taken a principles course in microeconomics, E1 maybe, or something like that, you've seen lots of pictures that have like a Q here, and a P here, and there's a demand function here, maybe a supply function, too. I don't know. So the question, which is a good one, is what the heck demand curve is this? In principles, you didn't distinguish between Marshallian and Hicksian demand curves. Does anyone have an answer? Yeah, so West wants to be a Marshallian demand curve, and that's exactly right. So this is these old demand curves you've seen before, and the usual demand curves when you do empirical work or quantitative stuff in Marshallian, because those are the things we observe. If you go off into, if you go look at some data on, prices for, I don't know, houses or food or whatever, what you wind up with is data on prices and quantities, and those are traced out by the Marshallian demand curve, because people's incomes in reality differ, and that affects, your demand. What the problem people solve, when they actually demand stuff, is trying to choose stuff subject to a given budget. They don't get to solve the Hicksian problem of, achieving a particular level of utility, because they have a fixed set of resources, not a fixed utility. So the Hicksian demand curve is tremendously useful for lots of stuff, but when we get real-world data on prices and quantities, it's tracing out. Those are points that are coming out from Marshallian demand curve. Okay. Yes. Oh, let's see. I hope I didn't screw up. So I multiply and divide by y. That's fine. You're absolutely right. This isn't. I shouldn't have done this. I shouldn't have done this. You're right. I can't multiply by these prices here. Don't do this. Unless the prices are the same. I should have just stuck with this thing. Thank you. Yes. Yeah. No, that's fine. So the conclusion is that we don't have this property of symmetry for Marshallian demand curves unless these two quantities are equal. And these two quantities, we can turn this. We can multiply. We can multiply both of these guys. Oh, I know what we can do. Hold on. I can do a little bit of this. Okay, so I'm going to take this expression, which is dxi dy. I'm going to multiply. Divide through by xi and xj on both sides. So I'm going to get an xj here. This is what I want. This is much nicer. Thanks. An xi here. And the question is whether this is equal to dxj dy. Xj. I'm going to multiply both sides by y, by income. That's good. Yeah. Okay, that's much better. Thank you. So Marshallians are symmetric if this is satisfied. And in words, this is just a statement that the income elasticities have to be equal. That's much better than this messy thing. Thanks. Okay. All right. Other questions? That was a really good one. Thank you. Okay, I'm going to switch gears a little bit and talk about a little application related to the demand for light that I hope will be interesting. We'll see.